Here are the MAT 1140, Chapter 7.2 recordings for the notes. These are solving linear equations. So, objectives are at the top. I'm not going to read those to you. But let us start with what we mean when we say linear equation. So, a linear equation in one variable. So, we're talking about only one variable. We've got an exponent of 1, and we want to talk about how we're going to solve these. Okay. We are going to solve these by making a series of equivalent equations. So we're going to use math to do things we're allowed to do and making sure that our equation stays balanced on both sides. But as we do this, we are going to simplify the equations. So take a look at example 1. We're going to use what's called the addition axiom. Mathematically, it says if I have an equation where two sides are equal to each other and I add the same thing to both sides, then my new equation will also have the same solution. It's also going to be equal. We're all good. Now keep in mind, we can always write a subtraction as an addition. So when we say addition, we're also saying we can subtract the same thing from both sides, and we're still good. Okay. So example, and we're going to think in terms of making zeros. Nothing magical is happening. I'm not just moving stuff. But if x plus 7 equals 28, the opposite of plus 7 is minus 7. What I've done here is made this a big zero. If I take a number and I add 7 to it and subtract, I get 0. So now on the left-hand side, I only have x. On the right-hand side, I've got a straightforward mathematical expression that I can simplify. 28 minus 7 is 21. B, I want to get the y by itself, so I want to get rid of that minus 10 part. So I'm going to add 10. And sometimes it helps, call these railroad tracks, to set the two sides apart. So you know when you're adding or subtracting, it is happening on both sides. And when I add 10 on both sides here, I get y equals 0. And 0 is a valid expression, a valid answer. 0 is a number. Example 2, now we're going to use the multiplication axiom. So just like with addition and subtraction, if I start with two things that are the same, then I can multiply by the same thing and get two things that are the same. Keep in mind, we don't want to multiply by 0. That's kind of cheating. This also works if we're dividing. Guess I should have left a little more room for those. Okay. So let's take a look at how we're going to solve these. If on A, we've got 7 times x equals 42, the way that we undo times is to divide. So I'm going to write it this way, over 7. And keep in mind, it's only the 7 I want to get rid of, not the x. So I'm dividing both sides by 7. 7 over 7 is just 1. I get left with an x here. 42 divided by 7 is 6. B, I'm going to kind of use a trick here because I really don't want to divide by 1/6. But dividing by a number is the same always as multiplying by the reciprocal. So I'm going to flip the fraction over and multiply both sides by 6. On the left-hand side, I'm going to write it as 6 over 1 because I think that helps seeing what cancels. On the right-hand side, I'm just going to write it as 6. 6's cancel, and we get P equals 72. Keep in mind, we can always plug our answers back in and make sure they work. See, there's a couple of different ways to think about this. Minus m, negative m, means negative 1 times m. If I want to get rid of that, I'm multiplying both sides by negative 1. 1's a little different. I don't always have to divide. Sometimes it also helps to think that negative m equals positive 19, so we can flip those. Positive m would be negative 19. Sometimes we have more than one thing to do. So we are going to start by combining like terms wherever we can. And again, I'm going to draw in the railroad tracks just to remind myself that left-hand side is different than the right-hand side. I can combine these. This says I have 1x plus 1x. That gives me 2x on the left-hand side. I have 11 plus 31, that is 42. Now, though, I have a number times x. I just want to solve for x. I don't want the answer for 2x's. So I'm dividing off the 2, and x is 21. Same thing on b. We still have the variable on the same side. 5x minus 2x is 3x. All I have on the right-hand side is 12. I don't have to do anything else. Divide by the 3 because I don't want 3 x's, I just want 1. And we get x equals 4. And we are going to go ahead and stop this recording here and do page 2 separately.